so that you have to make lessons during this time, 5 o'clock in the Friday afternoon. Remember that. So regarding your test yesterday, I hope no problems. I didn't see yet your answer, right? Your answer. No check yet of your answer. Right. And now we continue of section of chapter 3. Uh, Last time we talked about rational zeros theorems. If you still remember the plus minus c over d, is that? And now we look at one more, which we call it, we say, Descartes' rule of sign. Descartes' rule of sign. Uh, so Descartes' rule of sign said that let polynomial px with real coefficient and non-zero constant term, then one, the number of positive real zero equal to the number of variation of sign, or less than that number by even integer. So we have to look at that, how many variations of sign. If the variations of sign 2, so number of positive real zero could be 2, or less than that number by even integer. 2, the number of negative real zero is the number of variation of sign, the number of variations of sign, or less than that number by even integer. That's Descartes' rule of sign say. Therefore, if we want to find how many positive real zeros, how many negative real zeros, we use Descartes' rules of sign. Descartes' rules of sign will tell us that how many the number of real zeros, and how many the number of positive real zeros, and how many negative of real zeros. Let's say, for instance, for instance, given one polynomial 3x to the power of 4 plus 5x to the power of 3 plus 25x square plus 45x minus 18. A, use Descartes' rule of sign to determine positive and negative zeros. How many? B, list all possible. Talk about real zero, meaning that not complex zero. We just look at the real zeros. A, use Descartes' rules of sign to determine positive and negative zeros. Right. From definitions, when we use Descartes' rules of sign to know how many positive zeros, how many negative zeros, we need to know the number of variations of sign. A, make x is positive. So you take the value of x is positive in order for us to find how many number of positive real zeros. 3x to the power of 4, 5x to the power of 3, 25x square plus 45x minus 18. Right. The first one, we cannot see any variations of sign from here to here. No variations of sign again. No variations of sign again. But from 45x to minus 18, we see variations of sign. Therefore, only one variations of sign. So we can say that the number of positive real zero is either 1 or, I remember that the different definitions, 1, the number, or less than that number by even integer. So when we talk about even integer must be number, what is the number of even integer? What is the number we say that even integer, least of even integer? Least of even integer.
Is it 2, 4, and 6?
All right. So we minus 1 minus that even integer. 1 minus 2 will produce minus 1. We cannot take minus 1 because we don't take a negative number, because we want the number of positive real zeros. So number of something cannot be negative. Number must be positive. Therefore, we don't take minus 1. And also, when 1, you minus with another even integer, which is 4. 1 minus 4, minus 3, definitely minus as well. Therefore, you cannot minus with even integer, so it's only number 1. You get it? It's only number 1, only 1 positive real zeros. It doesn't mean that only 1 positive real zeros. Even though we have or from definition that we have or, but in this case, we do not use or. Why? Because when we use or, even integer will be 2, 4, 6. 1 minus 2 will produce negative. We don't take a negative number here. You get it? Right. Now we want to calculate the negative real zeros. This is positive real zeros. Negative real zeros. Negative real zeros. Okay. We substitute x with negative. What do you get? P minus x. 3 minus x to the power of 4. 5 minus x to the power of 3. 25 minus x. 45 minus x. Minus 18. Which is here is 3x to the power of 4 minus 5x to the power of 3. Here x squared. Plus 25x squared. You understand why plus, minus, plus? Now, here minus x to the power of 4, we get x power of 4. Positive of x to the power of 4. And here is negative, and power of 3 stay as negative. Minus 45x. Minus 18. Minus 45x minus 18. Right. Now you can see any variations of sign or not. See. One variations of sign, I see. Positive to negative. One variations of sign. Another variations of sign. Another variations of sign. No variations of sign. Therefore, we can say that the number of negative real zero is either 3 or less than that number by even integer. So what is even integer? What is even integer?
2.
So 3 minus 2, what we get?
1.
Okay. And then next even integer after 2?
4.
4. So 3 minus 4, what we get? Minus 1.
Negative 1.
We cannot take negative. Bear in mind that we cannot take. So it will stop at 1 only. So 3 or 1. In the case of positive real zeros, we stop at 1 only because 1 when we minus with 2, we get negative. So only 1. So depends on the variations of sign. Not take for granted that must always positive, always 1, and negative must be always 3 or 1. No. Depends on the case of our polynomial. You get it?
So how can we detect the variation of sign?
How do we know? How do we know variation of sign? So you calculate. Here. This must be positive. Positive to positive, no variations of sign. Positive to positive, no variation of sign. Positive to positive, no variations of sign. Positive to negative, yes, variations of sign. Only one variation of sign. But for negative, I see. Positive to negative, one variation of sign. Negative to positive, one variation of sign. Positive to negative, one variation of sign. Negative to negative, no variations of sign. Therefore, in this case, we have 3 variations of sign.
Alright, sir. Understood.
And when variations of sign is 3, so 3 O. We always have O. Even here we have O, but we have to stop. Because 1 minus 2 is minus 1. So stop. We don't want negative number. Like here, 3 or 1. Therefore, the next even integer is 4. Right, when 3 minus 4, we get minus 1. No, we don't want. So we just stop at 3 or 1. And that's discards rules of sign set. To determine how many supposed to be zeros of our polynomial. Remember that zeros of polynomial is some sort that make polynomial 0. Number which make our polynomial 0. That's the zeros of polynomial. Right. B. List all possible zeros. Now we go and use again rational zeros theorem. Rational zeros theorem said that list of all possible rational zeros will be plus minus C over D. So plus minus C over D. So we have to find what is C. C is 1. C is what? C is what?
Negative 8.
C is here. Factor of constant coefficient. Factor of 18. Factor of 18 will be 1. Will be 2. Will be 3. Will be 6. Will be 9. Will be 18. D, what is D? D is factor of leading coefficient. Leading coefficient in this case is 3. So D is factor of 3. 1, 3. So list of possible zeros or possible of rational zeros will be plus minus C over D. 1 over 1, 1, 1 over 3, 1, 2 over 1, 2, 2 over 3, then 3 over 1, 3, 3 over 3, 1, which we already have, no need to write. Then 6 over 1, 6, 6 over 3, 2. No need to write because we already have 2. Then 9, 9 over 1, 9, 9 over 3, 3, 3. Then 18, 18 over 1, 18, 18 over 3, 9. That's list of possible rational zeros. List of possible rational zeros. So if you look at the numbers here, how many? 1, 2, 3, 4, 5, 6, 7, 8. So 16 altogether. 16 numbers. However, this polynomial have how many zeros? How many zeros of this polynomial? How many zeros? Any idea how many zeros of this polynomial?
Four, sir.
4 zeros. Why we say 4 zeros? Yes, correct, 4 zeros. But why?
We look at the degree of polynomial.
Yes. Look at the degree of polynomial. Since degree of this polynomial is 4, degree of polynomial, how to know degree of polynomial? The highest power of x. So in our case, the highest power of x is 4. So that is the degree of polynomial, and also that is zeros of our polynomial, 4 zeros. And as I said before, even though 4 zeros, not necessary that we're going to have 4 different numbers. As you see, examples of the early stage, when we study this part, we have 3 zeros. For example, that I showed you on Monday, 3 zeros, but 2 numbers only. Still remember that? Why happen like that? Why happen 3 zeros but 2 numbers? Why? Why? You still remember on lesson on Monday? Lesson that I said to you that I want to stop early, right?
It has multiplicity.
Because of multiplicity. Remember that? In what game? When we talk about multiplicity, example that I showed to you, multiplicity 2. Yeah, but you may have multiplicity 3, multiplicity 4. Depends on this. This one is very important. Varies. Later, maybe a few minutes from now, different. And then different. So when different does not matter, different. You know that the degree of this polynomial. You know how many positive and how to obtain how many positive and how many negative real numbers. You know how to obtain the possibility of real zeros. By this, you use rational zeros theorems. This we use Descartes' rules of sign. Right. C, find all the real zeros. Remember that this word, real. Remember that number consists of real or complex, right? We want to find the real part. When given one polynomial, remember that zeros of polynomial not necessarily all real. Sum of polynomials consists of also complex zeros, which we are going to see later, not today. I think today enough for real zeros. Right. And now C is find all the real zeros. Okay. This polynomial, to find all the real zeros, we have to go back to the synthetic divisions because we want to factorize. As I said to you, remember that the examples of the Monday, polynomial given in polynomial form, in this general form, I wrote on factored form. That polynomial on Monday. Remember that? When I wrote on factored form, we can see clearly what's supposed to be our zeros. Right? That's on Monday. Now, this polynomial, we want to write in factored form as well. So, in order to write in factored form, because x to the power of 4 may be complicated. But complicated. So, one of the way, the easiest way is by reducing x to the power of 4, and then we reduce. So, to reduce, what we have to do? We go back to the synthetic divisions last week. So, for synthetic division, we list down all the coefficient. Coefficient is 3, 5, 25, 45, minus 18. And number supposed to put there? What is the number supposed to put there? Can you think one number that we have to put there?
15.
Huh? What? 15? What number you have to put? No, not 15. Definitely not 15. What number you have to put there? And why you choose that number? You give one number and why you choose that number supposed to put there.
Number 2, sir.
Number 2. Why you choose number 2?
Because number 2 is one of our possible zeros.
How do we know that number 2 is one of our zeros? How do we know that number 2 is one of our zeros? Huh? How do you know that number 2 is one of our zeros? Number that you have to put there is minus 2. Why? How do you know minus 2 number supposed to put there? Because when you substitute x with minus 2, our polynomial becomes 0. So that's the zeros of our polynomial, one of the zero of our polynomial. As I said, the definition of zero of polynomial is number which we substitute make our polynomial 0. So the number which we substitute to make our polynomial 0, one of the number is minus 2. We have another number. We have another number. We have another number. Right. I put minus 2. The reason why we choose minus 2, because minus 2 produces 0. We just not put one number. No. I must have a reason why we put the number. We choose minus 2. So now we start of the what we call divisions. 3 minus 6 and then minus 1 2 27 minus 54 minus 9 18 0. Therefore, okay, continue from here. Px can be written as, remember that when early stage we study polynomial, Px is Qx multiplied by dx plus Rx. So what is our Qx? What is our Qx? I said to you, when we study statistic division, the most right is remainder. This is remainder. On left of remainder is our Qx. Start from x to the power of 0, x to the power of 1, x to the power of 2, x to the power of 3. Therefore, Qx is 3x to the power of 3 minus x to the power of 2 plus 27x minus 9. Okay. That is QX. DX multiplied by DX. What is DX?
Negative 2.
X. Huh?
Negative 2. Our divisor.
Yes, what in form of DX? Negative 2 is our
X plus 2.
X plus 2. Yes, our divisor. Result is X plus 2. That's why negative 2 here. Plus Rx. What is Rx?
0.
0. Now, we do have, if you look here, 1 0 from here. 1 0. Another 3 0 will be here. 3 more zeros to be here. Understand? Why now become 3 zeros from here? Because power of polynomial. We see this is polynomial. This is another polynomial, but small polynomial. This big polynomial. Small polynomial now become the power is 3. X to the power of 3, 3 zeros. And how to find those 3 zeros? Factorize this. So since this is x to the power of 3, we factor what we call factor by grouping. One group, one group. I hope that you already encounter with factor by grouping before. If you still do not encounter with that, look carefully. We factor by grouping, which is we put these two in one group and these two in one group. You factor here. When you factor here, you see two terms. They consist of x squared. They share. They share. So x squared become common factor or factor sepunya. So to produce 3x cubed, x squared must be multiplied by 3x. To produce minus x squared must be multiplied by minus 1. That's factor of part this. Now, plus. We factor this part. Now, two terms, 27x and minus 9. So they share something. Number they share is what number they share? 9. 9. To produce 27x must be multiplied by 3x. To produce minus 9 must be multiplied by minus 1. That's one. We factor. We factor this part. This part still x plus 2. Remain. We don't do anything for this part because this part already x plus 2. You don't want to reduce any longer because it's reducible only. Already reducible. No need to reduce any longer. This part, factorization make x squared plus 9 and 3x minus 1. Remember that when these two terms same, we can do like that. X squared plus 9 multiplied by x minus 1. And this part multiplied by outside our bracket is always x plus 2. There. We don't do anything. And now we have 1 0 from here, 1 0 from here, 2 zeros from there. Right. So 1 0 from here is minus 2. 0 from here, what is 0 from here? What is 0 from here?
1 over 3.
Huh?
3.
Sorry? Zeros from here. 0 from here is minus 2. It's clear.
1 over 3.
1 over 3. Zeros from here. Zeros from here.
-1, sir.
No. Zeros from here. To find zeros from here, zeros from definition is something make zero. So we want to produce this part is zero. So what we have to do is x squared plus 9 will be equal to 0.
3, negative 3.
X
Minus
squared is minus 9. X is plus minus 9, not plus minus 3. So it will lead into what? This one will lead into what?
Complex number.
Complex. Therefore, we don't care because what we want is real. Meaning that this polynomial have 2 and 1 over 3 only for real. And the 2, x is either plus or minus square root of minus 9. This is complex that we do not write in the solutions. Unless the questions said, find all the zeros. When find all the zeros, we have to list down all the zeros regardless they are complex or real. So in this case, if you look, we have how many zeros for real zeros? How many?
2.
2. 2 complex. Right. We go back to the Descartes rules of sign. Descartes rules of sign, as we said that before, number of positive real zeros, 1. Yes. 1. Positive real zeros. Number of negative real zeros, either 3 or 1, in our case, 1. So this is not. Because they have all. All here means that can be. So in this case, 1 positive real zeros, 1 negative real zeros, and 2 more zeros, they are complex. Any questions? For part A, we use Descartes rules of sign. For part B, we use rational zeros theorems. For part C, we have to go back to synthetic divisions. Why we need to synthetic division? Because we want to factor our polynomial. If our polynomial is degree 3, easy to factor. But if degree more than 3, like 4, 5, 6, so definitely we need to use synthetic divisions. Which means that we reduce. You see, start x power of 4, we reduce to x power of 3. And then if we do again, we go to reduce to x to the power of 2. But from here already we can factor, so no need any longer for more another synthetic division. If we still cannot factor, we do another synthetic division. Rx, in this case, 0. Why we choose minus 2 here? Number you need to put over here, not just number you put. No, we put minus 2. And why we put minus 2? Because minus 2 is one of the zeros of Px. How do we know it is 0 of Px? Because when we substitute, our Px becomes 0. That's the meaning of zeros of Px. Not the number 0. Don't confuse number 0 and zeros of Px. That's the problem with the English language, to be honest, right? 0 kita kata kosong. Maksud 0 di sini, benda ataupun mana-mana nombor yang dimasukkan dalam polinomial menyebabkan polinomial jadi kosong. Itu zeros. Bukan nombor 0. Right. Any?
Sir,
Yes.
nombor yang nak letak dekat negatif 2 kan? Kan dia
Minus 2, ha?
kita ambil dia apa? Nombor yang akan jadikan PX tu kosong kan?
Ya, ya. Dan nombor yang kita pilih ni adalah bagi dia bersedarai ni.
Possible zero.
Sedarai ni. Tak boleh ambil nombor lain. Katakan awak nak ambil nombor 5, kan? Tak boleh. Memang confirm dia takkan jadi. Yang confirm akan jadi adalah nombor-nombor dan sedarai ni. Sedarai menunggu, sedarai-sedarai ni. Ini candidates. Macam kita nak apply kepada job ke? Ini candidates. Dalam banyak-banyak candidates, tengok. Ada berapa candidates ni? 18 candidate. 2 saja yang dipilih. Right. So I think I stop here. I understand that you are very tiring week now. Now we nearly 6 o'clock, right? All right. Thank you very, very much again for you to join this class, to join even though we in the late afternoon and I know that we are tired. So inshallah we'll see you back on Monday next week. Inshallah. So I stop the sessions today with Tasbih Kifara and Surah Al-Asr.
Thank you, sir.
Yes.
Thank you, sir.
Yes.
Thank you, sir.
Thank you, sir.
Thank you, sir.